Live from New York, it's Ask an Engineer.
Hi, everybody, and welcome to Ask Engineer. It's me, Lady Ada, with me on tonight's show, and on every show, Mr. Lady Ada on camera control, and also roaring like a lion. Rawr. We've got a fun-filled show for you tonight with lots of Python news, new products, INPI. It's not out yet, and more videos, 3D prints. We
A
have
lot
it.
going on
It's a
tonight.
lot. Why don't we get right into it?
So
Tell them
many.
what's the code on the show.
Tonight code is floats, 10% off in the Adafruit store all the way up to 11:59 p.m. Eastern time. That gets you 10% off in the store, including any free stuff we have as you add to your card. We'll be talking about some of our live shows that we do, including Show and Tell. We just did Show and Tell just a few moments ago. That's where we're running a minute late. There was a lot of projects tonight. Desk of LadyAda, where LadyAda talks about what's on her desk. We'll be going over what we did this week, including the Great Search. We got JP's product pick of the week. That's a live broadcast from the Adafruit store inside of a product page. Discounts automatically applied. We'll show the highlight. We got some retro tech. This is just a recap of a project that we did not too long ago. A really cool controller for the PlayStation. We got some advanced manufacturing, made in New York City factory footage, a little bit of a home prototype speed up too this week. We got some 3D printing videos, really fun one with Prop Maker. Pedro did. We've got new product introduction, Ion MPI. This week it is Sensata. We got some top secret, some really cool stuff this week. We've been really busy with some new products. Speaking of, we got some coming soon new products this week. They're about to hit the store. We answer your questions. We do that on Discord, adafruit.it/Discord. We got 37,000 people there, a few thousand people at any given time. Put your questions throughout the chat or just wait to the end and we'll get to them all. All that and more on Ask Engineer.
Bam. Oh my goodness.
Yeah. Okay.
Full
So
moon.
there's been a lot going on. Free stuff. You can get a Circuit Playground Express or a KB2040.
Yeah.
We're
More freebies coming soon.
More
We're
freebies coming
in a
soon.
freebie
Yeah,
transition.
and then also probably tomorrow-ish. So this will be our news segment, sort of. So there was going to be a UPS strike. There's not a UPS strike. Maybe there'll
Maybe.
still be a strike. Who knows? But we needed to make sure we had all the forms of shipping available in case anything could happen, because that's the only way you can live life now, is have backups of backups of backups. So one of the things we had to do is pause battery shipments because all the different shipping systems handled it differently. But I think starting tomorrow, if you want to order anything with batteries, UPS is active again for that. And then we also have what might even be active today. You could be watching this at any time. And then we have FedEx as the main shipping. We have Postal Service, and we have DHL for international. However, we're working with these carriers to figure out how to get you the best rates because we can kind of turn off any of these now and have more volume on one. So we're trying to figure out how do we get the best possible shipping rates for you. We don't add anything to shipping. We do a pass through. Some folks are like shipping's expensive. Yeah, planet Earth. It's how it is now. So we're going to just try to get the best shipping cost to you. I'll always suggest like we're not the store to get the one thing. Put stuff in your cart, get the multiple things, get free stuff, get free shipping after a certain tier. We're going to be adding that back as well. That's the best deal. If you want a one-off, if you want one resistor, get it from DigiKey. It's the best thing to
That's right.
do.
Wow, you just like covered everything.
Yeah, we do live shows
We do. Like this one.
like this one and others. So for show and tell tonight, there was a lot. In the beginning, we talked about open source stuff with Scott.
Yes.
JP had a project where we're trying to jam as many waves as
Cool
possible.
ambient technology.
Maker Melissa,
Making a gigantic display.
Noe showed the prop maker.
Remake of the prop maker. Previously, it was the Featherwing on a Feather
Yeah,
M4 making a lightsaber, which is what the prop maker was originally like
yeah,
designed for. But it was very complicated. Now the project is very simplified, less expensive, and he also showed that what the prints look like. You got it from a service. So it's
yeah.
30 bucks with shipping. Beautiful 3D
Yeah,
printed
we're at the
parts.
point where, a lot of people are like, oh, I like your projects, but I don't have a 3D printer. Man, And now it's like, no, here's a place you can send it to for $30. You get it. And
in a week.
there's lots of things. Some maker spaces are still around. There's 3D printers, but generally speaking, it's a pretty good deal. Your time is pretty valuable. So if you can get like the best print for $30, not so
I'll
bad.
be honest, like we have a 3D printer, and I was like, oh, I'll 3D print these stuff. I don't have time to put together the 3D printer
Yeah.
anymore. And we have a very good one too.
Yeah. It never seems to work when you need it. So we also had DJ Devin showed a Fitbit thing,
Yeah.
and then also I'll say it, it's an officially endorsed Adafruit hat.
Oh yeah, that's so cute.
And then Mark stopped by with a lightning detector.
Yeah, and it
And
worked
then
for Frisbee.
Bob had this really neat resistor
Yeah, that was interesting
software
because
generator
so
calculator.
you can do LED buttons sorry, you can do buttons as digital inputs, or that's normally like one pin per button. And you can have a matrix where you have like rows and columns and you scan them and you can put a diode in so you don't ghosting. Okay, there's that way. But apparently you can also do an analog to digital matrix. So you use one analog pin and you can read multiple buttons in. And there's a limit. You can't do more than like 12 buttons, but you can have up to 12 buttons in a grid with different resistors on the rows and columns. It's very interesting. I've never seen this type of input, but if you only have one GPIO pin available, you can get it done.
Yeah, and then Flying Things had a really cool update from a cosplay project where they're pressing their hand and it has different sounds and then also different things on the display.
The display, I think it was like a flexible OLED or something. Very cool.
And then Rex had an amazing badge that you just have to see. And there's this really neat side effect of the there's a side effect of the treatment of the PCB with the copper that you got to see. So check that out.
Cool.
I'm glad we were able to do show and tell because we rotate through the team. And so it was a full house. So do check it out after this show, of course. From the desk of LadyAda, every week LadyAda shows a bunch of stuff. So the part shortage has subsided a little bit. So after the 400 plus redesigns, LadyAda has been doing 406 has been doing a ton of new products. That's why we're completely out of our mind with caffeine and just like going a million miles an hour. And we have got a kid running around here too.
Yeah, she's almost walking.
Yeah, so that's going on. Yeah. So it's been around the clock, but we have a ton of new hardware design. So what did you show this week on?
I know. I feel like every week it's like, here's another big thing I'm starting. Like Scott, I was in a meeting once with Scott and he was like, baby's taking a nap. And I'm like, baby's napping, time to start a 6-month long hardware project.
Yeah.
So this week, one of the things that I'm restarting is in 2020, I was working with these really nice high-res TFT displays to create basically like the Pi TFT, but with a high resolution, using a 3.9 inch 800 by 480 display, like used for a phone. But like 2020 was just a kind of a mess. Then 2021 was also really a mess. And then I couldn't get TFTs for 2021, 22. But TFT prices are back down to like a reasonable cost now, and I can get chips. And so I was going to revisit this project and like get it back running again. And I realized I can probably also get this ICN 6211 chip, which is a chip that can do DSI to TTL dot clock displays. And recently I've seen more companies, like I think Waveshare and DF Robot, they have displays that plug into just the DSI port and they use the ICN 6211 and they configure it over I2C. Of course, all that stuff is closed source and like they don't release any of the code or the schematics or anything or how it's done. So I was like, okay, well, let's just redo it in an open source way so we can try all different types of screens. So not just 800 by 480, but square and round and like there's half round and there's like bar type displays. So I'm hiring local Code Ninja Timon, who worked on some previous display work with us for Raspberry Pi, to write library code for the ICN 6211 and also help with committing PRs to Raspberry Pi upstream to add support for all these different displays in an open source way so that other people can use them, especially since the apparently the compute modules, they have 2 DSI ports, but not a lot of other GPIOs. So it's like if you want to have 2 displays on a compute module, you could do it. So basically we're gonna have 2 gigantic eyeballs.
Yeah. LadyAda is being very diplomatic. I will be a little bit more direct. There are tons and tons and tons of people that buy stuff from lots of companies. They get it and it doesn't work. There's no form support. They're angry. One of them's Waveshare, another one's DF Robot. Sorry. They use our open source code totally fine. They often take our names off of it. Not cool. So instead of being angry about it and saying it's not fair, China, 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 or whatever, what we're going to do is just make sure there's open source code for all the displays out there. Yes, someone is going to copy it. Blah, 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 blah. They're going to do that anyways. But we're going to have something for people that will be updatable. So a lot of the stuff that happens, a lot of the challenges that we've seen that customers have from other companies is when Raspberry Pi updates,
The kernel
the
modules don't
kernel
work.
modules don't update. So now you have something that doesn't work.
Yeah.
And you're forced to use an older version of Raspberry Pi or something. So we're just gonna like fix all of that. And you'll be able to use any display that you bought with the open source code from Adafruit. Even if you get it from someone else, fine. But if you bought it from us, that would be nice too. But we have it's a big
Yeah,
effort for the
we're
year.
doing it. So we're starting with 800 by 480. Because the DSI port is a little bit simple. It doesn't have like, I don't say smarts. I don't call it stupid. It does what it does, but stuff like handling the backlight and handling touchscreen has to be done separately. So, we're going to get to all of it, but we're just starting off with like just showing configuring a simple 5-inch display. And then, we're ordering PCBs. So you'll see, as my PCBs and TFTs come in, you'll see that we're going to start adding support for all these different displays.
Yeah, so if you bought displays from all these other companies because we didn't have one or whatever, don't worry. We'll have stuff that makes it all work.
Make it work, and also we're gonna learn to see, because it's like we'll have the code open, people can modify it and be like, hey, here's an improvement.
Yeah, so that's what we're doing. Okay, and then you do the great search. That's when you go to digi.com and you help people find things they might need. What was the great search this week?
Okay, so this week on the topic of displays, on my Raspberry Pi 4, I broke the connector on the camera display, and I was like, oh, you don't want to throw away the whole Raspberry Pi just because the little clip broke off. You can just get a replacement connector and put the clip back on. That's rescuing your board. So somebody actually emailed and said, hey, like, what's the part number for this? Because the Raspberry Pi schematic, I think, doesn't have the part number. But I show on DigiKey how you can find a 50-cent replacement part.
Alrighty, and if you need help finding something, or if you need a substitution part, or if you're like, I wonder how to find the right thing for the thing, you can get a hold of us easily in every form, and we'll do a great search for you.
I will.
Yeah.
I have.
Okay, JP's product pick of the week this week. Take it away, JP.
It is the I2S Amplifier BFF. Here you can see I have the I2S Amplifier BFF soldered to the back side of a QT Pi RP2040, and then I've just plugged in one of these nice little speakers that have the Pico Blade connectors, so you can pull that right off depending on how your setup is meant to be put together. This is playing 3 wave files that I have actually all playing at the same time, and then I'm just changing their output levels in the mixer, in audio mixer. All happening inside of CircuitPython, and they're just looping sounds. And you can see this will work really well for projects that are maybe small props, little enclosures, costume things, sound players, toys, little synthesizers, and the like. So really nice, easy, basically plug and play. It is the I2S Amplifier BFF for QT Pi and Zhao.
Okay, and JP's workshop is tomorrow. On Friday, deep dive with Tim and special guest Scott. He's going camping, but he's like, I'm going to stop by. So check it out. Scott's back doing some deep dives. Tim will be there as well if you want to learn about the inner workings of CircuitPython. This show's for you, 5 p.m. Eastern. See some retro. All right, so this retro tech is a little different. We had used this in a project, and the photos that I wanted to get, I didn't time it right, so we did the project first, but now I got a chance to post these photos. What we're trying to do is have a virtual retro museum online of all of this cool old hardware, game controllers and everything, and use them in projects. So this is, well, actually, LadyAda, do you know what this is?
It's a PlayStation controller.
Yeah. So it's not what I thought it was at first. I thought it was like some type of color wheel that you would turn the wheel and it was
Like a
like
painting program.
yeah, it was like yeah, or like this calibrates your monitor. Nope, this is from Takara. This is the name of the company that made it, and it was for the Game of Life and some other like weird games. This is from 2000, and it's a PlayStation controller, and you spin it.
It's just a spinner wheel.
It's a spinner wheel, and definitely one of the weirder controllers. You can get these on eBay, and if you get these on eBay, you're probably going to say, well, what would I possibly do with this? And we have a guide that's available. It's the Game of Life controller, roulette controller for PlayStation. You can check out our Learn system. It was released in 2003. Looks like a roulette wheel, and it came with Game of Life, the Money Battle. There's a spinnable central piece, and then it's basically a random number generator for multiple buttons where you can bet on specific numbers or ranges. We showed how to turn it into something else. So you can use a QT Py RP2040 using CircuitPython, and then you can use that controller to use a USB HID keyboard, send in mouse commands, or make a USB MIDI controller, which is exactly the right thing to do with this.
It's got a funky look. It's got the buttons, but then it's got this kind of color. I actually kind of like the look of it.
Yeah, I think it's beautiful. I mean, like, all these old controllers of this like future we were promised. I mean, this is just neat. Like,
there's a lot of kerfing there.
Yeah, kind of like anything that has this. This is 2003, but I think it was originally introduced in the late 90s. Definitely has this like lawnmower man aesthetic. Like, this is what Job would use to
VR controller.
To suck in all the knowledge before he takes over the world's computers. Okay, that's this week's retro.
Okay. I remember when we met, you made me watch Lawnmower Man.
Yeah, gotta watch that again. Don't watch the next one. Python hardware time. All right, the big news is every single year we do CircuitPython Day. So CircuitPython Day is this month, August 18th, 2023. It's a Friday. We have a full day of programming and more. We'll get the word out for folks to participate. You'll be able to pop into our shows. It'll just be a full day celebrating all things CircuitPython, Python on hardware. Join us. Our newsletter went out this week, LadyAda.
Yeah.
And the newsletter has a bunch of projects. It's conference season. I'll get to that in a second. CircuitPython 8.2.1 was released. Anything super big with this one?
So it's a release, and there's a lot of bug fixes, and a lot of boards got released. But the really interesting thing is that we are getting started on what's going to be in Python 9. And USB host is one of the things that, it's not a secret. You see Scott working on it. USB host is going to be in there. So it'll be kind of neat.
Cool. We did a recap of the CircuitPython Hack Chat. Also, Hackaday did a recap on their site. You can read that as well. We'll talk about some whippersnapper stuff soon. CircuitPython Day. MicroPython added LoRa support. Tom's Hardware interviews EduBlock founder Josh Lowe. You can see a lot of cool CircuitPython stuff in that interview. Tons of Python resources, but the thing I wanted to ask you this week, LadyAda, because it is DEF CON season, it is badge season, we just saw badges on Show and Tell, is why in the world would someone ever choose Python over other ways to do embedded development for conference badges? And the reason I ask is today there was a blog post because there is Board Hack 2023 NFC badges, and I did get a chance to talk to the developer of this over email, and they said some really nice words, but I thought, this would be a good time to ask LadyAda, like, when people are thinking about making a badge, why would they choose something like MicroPython or CircuitPython versus other ways?
Okay.
Not saying anything's better. There's just different strokes, different folks. But why? What would be the benefits of choosing a scripting language like Python for a conference badge?
Well, one thing about conference badges is they're never done on time. they're always rushed, which is totally normal. They're a project. They use them for fun with friends. and you're usually kind of rushing around to get up, 10 to a couple hundred badges done before an event. And so speed of development is the most important. And what isn't important is not security isn't like, obviously it says at DEF CON and people want to hack on stuff, but it's not like you have to like keep all your code super private and compiled, and it's not like you have to make it difficult for people to work on. You want to make it really easy for people to work on. So one of the things about using embedded languages is, and I've covered this every time we do talks on MicroPython, CircuitPython, is the speed of iteration, especially for these big chips like the RP24, you have big flash memories, and the ESP32, which has like a very intense compilation process. Is every time you want to do something, you're like compiling and updating, and it's minutes. Like, and I do it all the time. Even with like Platform IO, you're kind of like waiting around a little bit. With embedded Python, that speed is like, it's so instant. Like you can try things and you're just like so fast, like seconds, like less than seconds. Especially with CircuitPython, where on save it restarts. And so if you're doing development on drivers or on LED animations or anything where you're like, look, it doesn't have to be like perfect polish. It just has to work good enough for me to go to this event. And the second big thing is the ease for which you can get other people involved. It definitely always, you have usually your booth, and you have
We were playing a word game. How many things have the word booth in it? And I did phone booth, voting booth, and then we did trade booth, and then there was listening booth. Anyways, we played word games.
He was very good at the booth one. I was not really on top of that one. He would definitely won. He definitely won that version of the game. At your booth, you're giving away the badges. Everyone's wearing them. And people want to hang out, and they're like hanging out with their laptops, and they're like, "Oh, I want to change the animations, or I want to change the message, or I want to hack on it. I want to reverse engineer, debug something." And especially this is like an NFC chip over here, and you're like, you want to read NFC tags and maybe emulate them. And I love embedded development, but it's definitely like now you're installing another version of Python. Now you have a new IDE. Oh, you've got the wrong version of ARM GCC. And then like 6 hours later, maybe you can compile and upload. And now you need drivers, and somebody's on a Mac and it's like x86 and it's the M2, and it's not they don't have it, it's not signed. None of that matters when you're dealing with embedded languages. You plug it in, it shows up as a disk drive, or you're using Thonny, or you're using, VS Code or whatever, and you can instantly start coding. The code is visible there. It's another thing people are like, what code is on here? I don't even know. How do I edit it? Because you have to like just get back to what the default code is before you can even start modifying it. But if it's embedded interpreted language, the interpreted language script is right there, and you can immediately work on it. I've done workshops where it's like 45 minutes just to get people to install the right drivers, to install the IDE, to like plug in whatever. That's all gone with embedded interpretive languages. Especially important at a place where like people are drunk, they're coming and going, they're going to a talk, they come back, they're like, shit, where was I? Wait, we're setting this on fire. We're like pushing Shipley into the fountain at the Alexis Park. You don't have time to install an IDE. You want to get onto it. So that's why I think
Okay.
CircuitPython's great.
My little odds and ends to add to what you said is they show up as USB drives if you use something like CircuitPython, so that's super easy. A lot of people have laptops. The other ththing is interpreted languages are great for strings, so like internet stuff, and that's where everything is heading.
Or like you're reverse engineering something, you want to get the strings and the data. You want to parse out bits and bytes and
then
shift things around.
A lot of these things, if they're not maintainable, when you get home, you just toss it or it just sits on a shelf forever. The way we set up CircuitPython, for example, when you go to circuitpython.org/downloads, there's always a new firmware for whatever you have too. So you can use this badge. And we know people have used badges with CircuitPython for years for other projects. So the developer of this particular one, I said, hey, can I share this? And Thomas said, yes, thank you. I really like CircuitPython for stuff like this. The low barrier of entry with the decisions of mass storage and auto reload on save, I find it great, especially for people who aren't programmers or electronic engineers.
Wow.
Yeah.
That's the point.
So yeah, and we were on and like, good news, bad news. We were on Hackaday recently, and there was some crummy comments. There's purists that say you should never have a scripting language on a microcontroller. But there were some people that had some insightful comments, and they said, look, expert gatekeeper jerk. I'm paraphrasing. Um, some people want to get started, and yeah, they can get to that, but they got to start somewhere. So don't be a jerk. Everyone was beginner once in their life. Not everyone is, God yet. So this is a great way to get started, and you can always add more complexity and skills. But if you want to get started, especially when people haven't been doing embedded development for 60 years or 50 years or whatever, this is a way to get there. And I guess the only thing I'd say is I think you get a more diverse, interesting group of people when you allow beginners in and you have beginners and something for them than if it's just like you're the expert that worked on AS400 and there's like 4 of you left on planet Earth. Like, I think you want to meet new people too. So, anyways, that's
Python hardware.
that's Python on Hardware. You can get all of this exciting news and more. Adafruit Daily, delivered every single week. Okie dokie, let's keep going. We have some news. Adafruit IO has exciting updates. You may have seen that we have 1,000+ devices, including Whippersnapper, but wait, there's more. There's 20 development boards that work with Whippersnapper IO. Brett has been really busy with this. We also have been adding more folks on the team.
There's a lot more devices
Yes.
coming, so
So the boards right now that if you want to start checking this out, anyone can add boards, but right now the Raspberry Pi Pico W, the Feather has ESP32, ESP32 S2 Feather, the reverse TFT Feather, the TFT Feather, the Feather with no PSRAM, the 2 MB PSRAM, the TFT Feather, the S3 TFT Feather, the V2 Feather, the Huzzah, like it just goes on and on and on and on and
a
on.
lot of info. But remember, if people want to submit their own boards, it's really easy. You don't have to support just our boards. We're very happy to support others. As long as it's within platform IO, which I think like, anything that's ESP32 is definitely in there. Please submit it, just
Yeah.
pick CircuitPython. We have a tutorial on how to do it. We would love to support other people's hardware. We're just so busy fixing
Yeah.
our own bugs. We haven't gone around to
So this is much like what we did with CircuitPython. There's more non-Adafruit boards than Adafruit boards. So Whippersnapper, there'll be Arduino boards in there. There'll be a lot of non-Adafruit boards. That's why we did that. If you look at the other IO or cloud services, you're locked to their hardware. We're not doing that because that's how we are. Okay. It's open source hardware news. Speaking of, we were a little behind with our certifications, but we're getting caught up. I think we have 590 plus OSHWA certified boards.
We definitely have we're up to 600.
Yeah.
We have to submit them.
Yeah, we got caught just in a backlog, but
they're happening.
yeah.
I'm also going to try to do it as we have new products come out. We're going to do the certification then, not try to batch them out because I think that didn't quite work out. And
again, like if you've been watching the show, the reason we do this is I'm seeing a lot of people say how we love open source, we love users, but then everything's actually closed and hard to do. If you really like users, then you can send the signal, which is here's all the stuff in a way that you can use it without ever talking to us ever again. What's the phrase? If you love one, set them free. If you love your users, free the files. So we have these guides. And I have one video. You want to talk about the guides we put up?
We have some guides this week. Liz wrote up a guide for the TSC 2046. It's an SPI resistor touch screen controller. We also have the TSC 2007, which is the I2C version. We're going to be using these in some coming up boards. They're a replacement for the STMPE 610 and 811, which discontinued over COVID. Very sad. We also have this cool lightsaber prop maker build using the new prop maker RP2040, which makes this build much, much easier than before. The prints is much easier to put together. There's a lot less soldering. It's only 3 or 4 solder points. So it's much easier for beginners. I could say it's actually a beginner project now, whereas before it kind of wasn't. Everything's integrated, and of course the speaker is also a digital speaker, so the quality of the audio is much better. And Kenny also wrote up a guide for the analog devices Featherwing. It was an older product, but we never wrote a guide for it, even though we have guides for the individual sensors. Now we just have one tutorial that covers both. And also Kenny wrapped up the ESP32 S2 reverse TFT Feather guide. We didn't have the CircuitPython Essentials. Now we do.
Okay, we have a video that I thought we would play. It's from the MIDI project from Liz.
In this project, you'll build a MIDI controller that uses 16 rotary encoders to send MIDI control change messages. Inside the case is a Feather RP2040 running CircuitPython code. The rotary encoders are soldered to quad rotary encoder breakouts connected over I2C. The interrupt pins on the breakouts are being used so that the I2C port doesn't have to be constantly pulled to check for any rotary encoder movement. This makes reading the rotary encoders a lot faster. The MIDI Featherwing lets you use a traditional DIN5 MIDI cable to connect to your music gear. A lot of music gear has MIDI functionality for controlling various parameters, like this guitar pedal. In this demo, the MIDI messages are changing the selected effect, which is otherwise controlled by one of the toggle switches. You can update the CircuitPython code to use MIDI messages for your preferred effects pedal, synth, or noisemaker. To see how you can build your own, check out the Learn Guide at learn.adafruit.com.
And rolling right into some manufacturing. All right, that's factory footage this week. Let's do some 3D printing. We're gonna roll right in. Do a speed up IMPI after that. The new products, top secret. We're zooming.
Become a Jedi or Sith and build your own lightsaber with 3D printing and electronics from Adafruit. Powered by Adafruit's RP2040 prop maker Feather, this iconic prop just got a whole lot better. The all-in-one dev board is engineered for making props with motion-activated lights and sounds, with better sounding digital audio and a lot less soldering. It's our easiest build yet. This new lightsaber features a color changing mode so you can experience a new vibe whenever the mood strikes. The RP2040 prop maker Feather is Adafruit's best dev board for your next prop build. Featuring the RP2040 chip, it's got a 3-watt digital I2S amp for excellent audio quality, NeoPixel driver, and USB-C for battery charging and programming. The hilt was redesigned to be more ergonomic and the parts screw together for an easier assembly. The pommel can be unscrewed and the feather slides out of the hilt for reprogramming or charging the battery. The parts can be 3D printed without any supports using filament, or you can 3D print them with a resin-based 3D printer. If you don't own a 3D printer, you can use an online 3D printing service. We had these parts printed on an SLA 3D printer using black resin. The service also sanded the parts for a smooth matte finish, and the parts only cost us $30 US. The CAD model is open source and parametric, so you can customize the design or use the models of the electronics to create your own. Programmed in CircuitPython, the code, libraries, and audio files are all accessible, making it customizable on just about any computer. The onboard accelerometer is used to read movement and tap detection for the swings and hits. The button uses the debounce library so that a long or short press can be used for cycling between the different modes. Long press to go in and out of the color changing mode. The background audio lets you know when it's active, and the RGB LED matches the color of the NeoPixels. Just plug in a USB-C cable to start charging, and the Feather shows up like a USB drive, making programming much more accessible. We think CircuitPython is the best for making advanced props, even if you're just getting started. To learn how to build your own, check out the guide at learn.adafruit.com. We had a great time remaking this project and brought it to Star Wars Galaxy's Edge at Disney World. Being able to go from Jedi to Sith was super fun, and the kids really enjoyed cosplaying with it. We hope this inspires you to check out the RP2040 Prop Maker Feather for your next project.
I'm brought by DigiKey and Adafruit this week. It is Sensata LadyAda. What is the MPI of the week this week?
I'm glad you asked. This week's is Sensata. We've not covered them before, but them and Cryden, I think Cryden is their sub-brand, make solid state relays, and that's what we're going to talk about. Their Series 1 hockey puck SSRs. They have a bunch of, this is a generic image. The one we've got actually triggers off of DC at a lower voltage. But DigiKey carries a lot of relays. Like I kind of went to the relay section. They have like 30,000 different options. And relays look usually something like this. Cryden, Sensata don't have non-solid state relays. They only make those, but this is a mechanical relay. And this image from the DigiKey site shows on the right, you have on the left, you have an electromagnet. And when current goes through that copperish coil, it turns into a magnet, which then pulls the two flanges on the right together and make the contact bridge. They join together, thus connecting the circuit. And, you know, people have been using electromagnetic relays for a very, very long time, and they're inexpensive. And again, there's hundreds of thousands of them available, different sizes, configurations, currents, etc. They can switch AC or DC. All's good, but there's actually two kind of big deal problems with mechanical relays. One is that, and this is the one that happens the most, is they have to be replaced after a while because the contacts are only rated for a certain amount of clicks, connections, and disconnections. After a while, especially if you're switching high currents and high voltages, you'll get arcing on the contacts, and the contacts, even if they're gold plated, will eventually start corroding. You see, this is an image from Wikipedia on the right. On the middle left, that's what a clean contact set looks like. On the middle right, that's what corroded contacts look like. And so a lot of relays are designed to be plug-in. So you unplug them basically and replace them when they've reached their life limit. And so often, you're like, oh, the local stoplights stopped working. It's because the relays inside broke and they just have to be replaced. The other thing with mechanical relays is they're slow. Like the electromagnet has to turn on, and then the magnet has to pull that flange of metal over from left to the right. And so they're not fast. You can't, for example, use them to like PWM to dim lights or dim high power heaters or whatever. You can only use them to turn on and off, which is, again, fine. But sometimes you want more control, and that's where an SSR comes in. So there are there's many families from the and sizes from Crichton Sensata. We're going to just talk about series one, but they have a couple different variations. Some of them can do AC, some of them do DC, some of them do have back-to-back SCRs, and some of them have thyristors. And, they have documentation showing all the differences between why you might want one or the other. And these are often used in, robotics, automotive, automation, where you're switching huge amounts of current. For example, we had our oven serviced only about a month ago. So you had to open up the oven, and you can see on the bottom there, those blue things, if we zoom in, those are the controllers for the heating elements, which are, like up to 100 amps total across all of the different heating zones. So these are like, easily 20, 40 amps at 200 plus volts. You can see the, hockey puck style relay down there, each blue one wired up to each set of heaters, multiple heaters for top and bottom. So not surprising that they use SSRs. You want something that's reliable, that can switch a huge amount of current and won't fail on you. Especially you don't want an oven to fail and the contact sticks and then it like stays on. That's no good. This latest family from Crichton has a couple, niceties added, basically improving thermal performances and making, cables, the internal connections thicker. So inside this hockey puck design is a circuit board that has, an opto isolator and circuitry that will switch on and off the AC current output. So the inside of it is not that complicated. So you want something, you basically want to make sure that you have one that's easy to heat sink, has good accessories, fits well, is designed safely. Some things I like is that on the top left they have anti-rotation barriers on the terminal blocks, and on the back they have a really nice flat area for the heatsink to connect, which we'll talk about. So if you look for this family of SSRs at DigiKey, there's about 3,000 options. Again, we're only going to talk about like one in particular, but all of them have very similar setups. You want to make sure that it's rated for your voltage, input and output, and particularly some of them only do AC, some of them can do DC as well. You'll see here like the wiring diagram that shows the inside of it, and then you can have the load on either side. But they are opto isolated, which is kind of nice. And a lot of them you can drive from little as 3 volts DC. You tend to be able to drive them from DC or AC, but the output, sometimes you can only drive AC depending on what's inside. For example, this one, the one I picked, can do up to 280 volts AC, up to 90 amps, and can be controlled from 3 to 32 volts. There's 2 output types. There's the zero cross and instantaneous. It is easier on everybody if you only switch current on or off on the zero crossing, or at least, switch off on the zero crossing or switch on the zero crossing, because then you don't have as much inrush current. However, there are some times where you might want to turn on or off in the middle of the cycle. And so some are kind of set up to do one or the other. It's another one of the configurations that's often set up. All these have the same kind of chassis mount. And they have different current ratings. You're going to pay more for bigger current ratings. So they start at 10 amps, they go up to 125 amps. But each one of them has basically the same forward voltage. And that's one thing you have to watch out for when using SSRs. One thing that's nice about relays is, besides just being inexpensive and plentiful, is they don't need heat sinking, because the contact resistance is nearly negligible. There's no circuitry inside, so you don't have a forward voltage drop. You don't have a voltage drop across it. Whereas these, if you see kind of on the top area, middle, they say maximum on-state voltage drop at rated current 1.15. So that's 1.15 ohms, which means that as you are, volts, which means as your current goes up, 10 amps, now your peak dissipation is 11.5 watts. up to 100 amps, now you're talking about 115 watts that you might have to dissipate. And these come up to 90 amps. So yeah, we're talking about 100-watt dissipation. And the circuitry inside definitely cannot handle dissipating that much current through the past transistors on the output. So what you definitely need to do is have heat sinking for them. And that's a very common issue with SSRs is, you're like, how come I can't control the current that I think I can? It's because you're not dissipating the current off of it. You're not dissipating the power off of the body of the SSR. So Crydom has some documentation showing here's how you do the calculation. You basically treat it like it's a transistor, but it's just very mechanically large. Maybe I'll show it on the overhead real fast because I happen to have this. So this is the relay. I just got the it's only, I think, 25 amps out maximum, the 1225, low voltage input, high only up to 100. Yeah, so the 12 here is 120 volts AC and 25 amps. So this is kind of the least expensive, most common for basic American or Japanese power. And then on the back, you see you use these to bolt onto here, and this is your nice flat heatsink surface. So don't forget to also pick up a heatsink, and they come in different sizes for the different amount of degrees per watt you'll need to dissipate. Do the math, right? You can get away with, looks like the HS 172 if you're only dissipating 10 watts, but if you're doing 100 watts, maybe you'll have to check out that HS 201 DR, the gigantic thing in the middle there. They're going to be more expensive the bigger they are. So, and of course, they'll take up more mechanical space. I have so far not seen any actively cooled SSRs. I think that they're not done because it's just another thing that could possibly go wrong with your setup. Okay, next up, they also have covers. Yes, I actually got one of these. It's quite nice. Cheap SSRs don't come with covers. Some of these, the SSRs actually come with them already attached in, but I really like it. It's a nice clear safety cover. Protect you from the SSR, it's high voltage, and protect the SSR from you. You don't want your oily fingers getting all over the contacts and possibly loosening them. That's no good. So this is the one I picked, but there's a gigantic family of them. But this is the 25 amp, 120 volt AC version. What I particularly liked about it is you could control it from as little as 3 volts DC. We have a video that they posted showing how to test it, which is a common thing I've seen from people. They're like, I don't understand. There's no, I'm doing I'm doing a contact measurement using an ohm meter on the output when I switch it, and I'm not getting a beep. Why not? Because it's solid state. It's not mechanical. So let's check out the video.
Yeah, longest video for this segment, but we think it's worth it.
Really good.
So watch it.
Welcome to this edition of Crydom Tech Lab. One of the most common questions we receive through Crydom Tech Support is, how does one perform a simple operational on-off test on a solid-state relay? We will demonstrate such a test here today. Unlike electromechanical relays that can be giving a basic test with a continuity checker or ohm meter, solid-state relays, SSRs, require a minimum amount of load current to switch. Testing with a meter does not present enough of a load on the SSR to allow it to turn on, and there is no mechanical contact closure within to show continuity on the meter. Additionally, since an SSR is by definition a relay with no moving parts, there is no audible click to provide confirmation that the input is actuating the output. All of that being said, the basic setup and operational bench testing of an SSR is quite simple. Note that line voltage will be present during this test on various terminals, so be careful. For this demonstration, we'll be testing a Crydom D2450. This is a DC input, 240 volt, 50 amp AC output SSR. Since this particular relay output is usable on AC line voltages from 24 to 280 volts AC and requires only a minimum load current of 40 milliamps, Using a standard 25 watt lamp and a 120 volt source is perfectly adequate. The wiring is quite simple. Here are the connections. One side of the 120 volt AC line goes to one of the SSR output terminals. It doesn't matter which, either number 1 or number 2. The other side of the solid state relay goes to one side of the load, and the other side of the load comes back to the other remaining AC line connection. For testing purposes, there is no particular attention needed for hot or neutral connections. A solid state relay will switch either leg. The last item needed is the input power signal. With a 3 to 32 volt DC input SSR, such as the Crytum D2450, a single good 9 volt battery is a convenient input source. Just be sure to observe the polarity. The plus of the 9 volt battery needs to go to the plus terminal number 3 of the relay input. If the SSR to be tested is an AC input type rather than a DC input as this is, the input signal would of course need to be the appropriate voltage. The first test step is to simply apply the line voltage while observing the lamp. With the D2450 being a normally open relay, the lamp should remain off when power is first applied. If the lamp is on at this step, then the output of the SSR is shorted and therefore bad. If the lamp is off, the next step is to see if the output will switch on when the input is applied. By touching the 9 volt battery terminals to the input terminals of the relay, the lamp should come on if the SSR is good. Removing and applying the battery should correspondingly flash the lamp on and off. As seen here, this solid state relay passes the basic operational test. There are many more detailed tests that are performed on SSRs at the factory during production, but a simple bench test performed as shown provides a quick indication of SSR operation. We hope this has been helpful. Thanks for watching this edition of Crytum Tech Lab.
On MPI.
Okay. We're zooming.
We're zooming. We have a couple of, they're not out yet. They're coming soon, but I wanted to show them off. One is I've got this PC joystick to seesaw converter. So if you have one of these old school joysticks and you want to connect to I2C, you'll be able to do it with this breakout board that has an AT-Tiny that acts as a seesaw converter. So you can do the analog reads for the joystick and the buttons as well. It's got also IRQ, and it's like fully assembled, and you just plug in your joystick. So this is coming soon. Next week we'll have a demo.
This would have been the star. We'll have them in shortly, but this is hot off the press.
Yes, these also came in, and this week was a little nutty, so I didn't get to make the tester yet. But coming soon is the Metro RP2040. It's got your RP2040 chip. It's got two ways of doing debug, either the Pico probe or the SWD port. It's got the Arduino shape, USB Type-C for programming and upload, all the Arduino pins, plus SPI, I2C, DC inputs, 6 to 12 volts, micro SD card, which is also wired up for SDIO for people who want to do SDIO configuration stuff. NeoPixel on board. I mentioned 16 megabytes of flash. The buttons are on the edges. And a funky thing, because I wanted to make sure that you could either use the Metro with a numeric pin order 0, 1, 2, 3, 4, 5, 6, 7 through 13, or logical pin order where the first two pins, usually D0 and D1, are the hardware serial. There's a little switch so you can slide and switch the orientation of them. Also an on-off switch for the DC jack. So, you know, basically you want to upgrade your Metro designs. You have something that's needs an Arduino shape. You want to use a shield with it, but you want the power and flexibility of the RP2040 with all those PIOs. This will be great. So coming next week.
Jumping right into top secret, then we're going to do some questions. Then we're outie. We're going to play 2 quick videos. Lydia's going to talk about what's on the other side. You're going to like this one. Here we go.
All right, LadyAda, what is this?
It's 10 o'clock at night. Do you know where your hardware is? Well, you will when you have this RTK board. This is a precision GPS and real-time kinematics location shield that we've designed here. So I got 2 of them. I don't even want to talk about how expensive these are. So it was really stressful when I first plugged in the USB, and I was like, I really hope it enumerates. But this actually has native USB, and I've got it connected here. I soldered on an SMA connector, and this is going to a U-Blocks antenna that's out the window. Thankfully, the window isn't too far away from my desk. And you can see I've even got pulse per second, RTK signal, and then what's interesting is that this just shows up as like a COM port. And then over here, I've got the U-Blocks U Center. And you can see it's seeing satellites and data. So a really good start. Next up, I have to figure out how to connect, one of these as a base station to one of these as a rover and communicate between the two. I might use our new Metro S3 as the transport layer. So, solder this on top and then use this either ESP now, perhaps, or Wi-Fi or Bluetooth Low Energy to transport the RTK data between the two, and then they can tell exactly how far apart they are. So just started like 5 minutes ago, just plugged this in, but thankfully we're off to a good start.
All right, LadyAda, what is this?
This is a 5H 800 by 480 display, and it's connected up to an ICN 6211. This is a very interesting chip. It's not very well documented, but what it does is it takes DSI, so MIPI signal, and converts them to RGB TTL. So it's got like 8-bit red, 8-bit green, 8-bit blue, VSync, HSync, data enable, on, off, all that good stuff, pixel clock. So normally, if we were going to drive a display like this from a Raspberry Pi, you'd either connect to the HDMI port, which means you need an HDMI to TTL converter, and that's like the RTD 2662 and friends, or like a TFP401. But what's nice about this chip is it doesn't use any of the GPIO, like they're not connected, and it doesn't use the HDMI, and you still get really good quality video, and this chip is like only $2. So this is a fun little demo coming soon to the Adafruit shop.
Okay, so this is a photo from this book. This is the board. Why is this a big deal?
This is cool because, historically, if you wanted to connect displays to a compute module board or Raspberry Pi, you'd have to use either all the DPI pins, all the GPIO to connect to DPI display, or HDMI, which requires like a high power HDMI to TTL converter. There are existing projects that use this ICN 6211 to convert DSI to TTL, but like none of them are open source and documented. None of them are going to make it easy for you to add your own screen. I want to make it easy. So I'm going to open source everything and publish and document it. I don't know if I'm going to release this particular deck board. I might, just to be like, hey, for folks who really want to experiment, you'll need to connect all the pins and ports together as you desire.
Explorer board.
But maybe it's be ICN Explorer board. But this is for standard TTL, and then I also have a version for the other 40-pin version, which requires an onboard microcontroller to set the SPI commands to turn the display on. There's like 2 standards apparently. So I'm learning a lot as I'm doing this.
There's a lot of like, this is so terrible for everyone. How could they do this to human beings? Wait, we could maybe fix this.
Yeah.
So, coming soon. That's
Yeah.
great.
It's happening.
Okay, questions. They're lined up. We're gonna do this.
Okay. Question.
Yeah, here we go. What's the normal lifespan of a good relay?
I think it's like 100,000, maybe 10,000 clicks. I don't know, but it's going to be in the data sheet for sure.
Okay.
It's like the mean time between failure.
You were working on some updates to the My Little Hacker board. What's the latest of these getting into the store?
The latest of these is Scott is wrapping up USB host, and then we're going to work on the Wi-Fi workflow. I want to get that a little bit better. The board is like pretty much done. The only thing is, some people are like, oh, I had to, we had Bill Smith he got one, and he's like, oh, I had to cut some of the plastic, and so my thing is like, should I try to redesign it to move the Wi-Fi module so you don't have to cut this little piece of plastic, or just say like, hey, you gotta cut a piece of plastic?
Yeah.
I don't know, but
Okay.
we're
Sign up.
I want to make
We'll give you updates when it's close.
software and hardware need to
Okay.
work.
For the Adafruit IO SSL cert stuff, so the airlift, what do they need to do? They need to get another cert?
Yes, so the root certificate changed this year, which was not expected. We didn't know that was going to happen. Normally, the root certificate does not change. Only the main SSL certificate changes, but nobody notices because you have the root certificate, and so you have this chain of trust. But the root cert changed. It happens every 10, 15 years. This was the year it happened. So you'll need to update if you're running an airlift and you want to use Adafruit IO, you'll need to update the NINA firmware. But there's a guide on how to do it. And I think we just did a release of 176. So follow that tutorial to update the ESP32 and you'll be good for another 10 years.
Okay. And then I saw that Jenny May was asking about a music playing and an audio jack thing with Raspberry Pi. Looks like they got help in the chat, but if there's any follow-ups, Jenny, let us know in the chat. You can also, stop by in the forums or whatever, but it looks like someone had answered your question already. Next up, would we be interested in, or open to designing and manufacturing the official DEF CON badge in the future? Maybe. It's one of those things where like we don't do contract manufacturing, but we're always interested in something. Maybe if it's super weird or it's using like an advanced chip, just let us know. We'll be.
I started. It's an electronic badge this year. We guess we'll find.
I don't know what the official badge is.
Yeah.
But I'll give you one example. So the open source folks, they did an event. They contacted us like a couple of weeks right before the event. They're like, "Would you do a badge?" And it's like, there's just no time to. It wouldn't be fair to our team, and it wouldn't be fair to them. So
Joe Grant starts the year when DEF CON ends, he starts writing the next year's badge.
But I feel like at this point, with the supply chain that's a little bit more reliable, I think, if you start now, the answer is closer to yes than if you ask us in June. And then any updates on the Teddy Ruxpin hacking guide? Yeah. We have a bunch going on.
Aaron, I know Dale Smith is working on his guide, and Erin is working on her guide, which is actually taking the innards of the Teddy Ruxpin and putting it into a different toy. But yeah, the guides are actually being written like right now. It should be on in a couple weeks.
Yeah. I did see someone on the socials. I think they're using our stuff to mod the eyes and also the voice, and it had like a pulsating like red eyes.
The code is in GitHub. It's called SNX ROM. It's in our GitHub if you just search for SNX ROM.
You can mess with it now.
And you can totally mess with it, but we don't have step-by-step instructions yet.
Okay. And
okay.
What's this? I think I got to all the questions.
Okay.
That's it, folks. What a day.
It's been a
day. If I told y'all what was also going on, just like regular running a business, and then all the stuff that's happening in the world, and then sometimes we get asked to help out in some pretty gnarly situations, and we do. I was telling, we were in a meeting before the show started, and I dated myself because I'm like, do you ever see Quantum Leap? And like Scott Bakula would like jump into this body in the past and try to make all the wrongs in history right. Sometimes I feel like that, and it's terrible because there's a lot of wrongs, and we try to fix them and everything. But man, it's not great to see people be terrible to each other. But I'm glad we're able to help when we can. Sometimes it's a technology solution. Sometimes it's mediating a dispute. Sometimes it's saying, hey, like, you got to be better to one another. And I guess it means something different when it comes from the war army. I don't know.
Are we going to stop doing what we do?
I guess stop what we're doing. But boy, it's been a week already. So we'll see everybody.
It's Wednesday.
Yeah, we'll be back. We'll be back. We'll see everybody next week. This has been an Adafruit production. All I want is Wingstop. No, we'll see everybody.
There's somebody named Squid in the chat.
Yeah, I will. Yeah.
Squid.
Yeah, and here's your moment of Xener. Be good to each other.